All right, let's get to our last section of chapter 5. So this is when I was talking about where we're going to be using long division with polynomials. So before we actually get to doing it with polynomials, let's go ahead and review long division just with numbers, just so you can kind of get the feel for it again if you're feeling kind of rusty. And if you feel pretty good about it, this is still going to be good because I'm going to be talking about how it relates to doing long division with polynomials. All right, so I'm just going to take some example. Let's go ahead and divide 27 into 6,696. All right, so now remember for these, the setup for this one, if I were to write this as a fraction, we're taking 6,696 dividing it by 27. So this part, the one on top, the dividend goes on the inside, the divisor goes on the outside. So let's go ahead and start dividing. So remember, we want to find the smallest number that this 27 can go into. So we can't put 27 into 6 because it's too small. It's going to be the same thing with polynomials. We're going to take a single term and divide it by a single term. You can't divide one term by two terms, so it's always going to be one by one. So let's go ahead and divide 27 into 66 because it does go into there, but we don't put it into the whole number quite yet. So I'm going to take 66, and normally you don't write this all off to the side, but we're going to be doing this with polynomials, so I'll do it for this one. So we're going to take 66 and divide it by 27. So it's going to go into 66 twice. So that 2 goes up top. And then if you remember, we're going to multiply. So 2 times 27 is going to give us 54. And then we subtract. And now one thing you don't really notice with numbers, because subtracting them is just kind of second nature now, when you're looking at polynomials, we're going to be distributing this minus sign in to every single term. And you can kind of think of that as happening in this one as well with numbers. We're doing 6 minus 5, and we're doing 6 minus 4. So we're kind of distributing it, we just don't write it with numbers. All right, so we subtract, and then we bring down our next number. And just one, we'll just be bringing down one term, and then we repeat. So we're going to divide, so 129 divided by 27. And so if we do that, we get 4. And the 4 always goes up top, and then we multiply again. And remember, it's just that new one that we put up there. So we're going to take 4, multiply it by 27. 4 times 27 is going to be 108. Subtract. So we got a 1, 2, 0. Bring down again. We're going to bring down until we're left with no other numbers to bring down. And then divide once again. So 216 divided by 27 is going to give us 8. 8 times 27 is going to be 216. And so we get 0 when we subtract. And so remember, this down here is the remainder. And when you divide, you can bring in decimals and keep bringing down zeros. With polynomials, we can't bring in decimals because we just have terms. We don't have a number that has decimals in it. So what we're going to do with whatever we get for the remainder, let's just say we got a remainder of 2 here. If we had a remainder of 2, squeeze this in here. If we had a remainder of 2, then we would have 248, which we have up top. And instead of adding in decimals, we can write it as 2 over what we were dividing by, which is 27. So we're going to do the same thing. We're going to put our remainders on top of a fraction at the end of our answer. The only difference is it's going to be added or subtracted on at the end, depending on the sign. And that's dividing with regular numbers. Now let's go ahead and try dividing with polynomials. So let's get started with our examples, and we're just going to be running through some examples. This is all we're doing in this section. Number 1, we're given 4x squared plus x minus 18 all over x minus 2. So now the big thing to remember here is what we saw last time is if there's a single term on the bottom, you can split this up into 3 different terms and simplify each of those fractions. If there's more than one term on the bottom, you must use long division. So it doesn't matter how many are on top, as long as you have 2 or more on the bottom, we're using long division. So x minus 2 goes on the outside, and then on the inside, we're taking 4x squared plus x minus 18, dividing it by that x minus 2. And so what we're going to do is we're going to follow the same process. We're going to divide, put that number up top, multiply it, and then we're going to subtract. So the way I remember this, if you've been on campus at all, you know the building DMS. That's one way you can remember the kind of process for this: divide, multiply, subtract. Because it really is just that same process over and over and over again. It's just a matter of getting used to it. So let's go ahead and start. The only difference is we're not going to put x minus 2 into the first 2 terms. We're always going to take the first term divided by the first term. So I'm going to put this off to the side. We're going to have 4x squared divided by x. And then let's go ahead and actually divide that. So remember, our x's cancel, so we're left with 1 on the top. So this gives us 4x. That's going to go on the top here. So as our divide, then we're going to multiply, and we want to distribute it to both of these terms. So 4x times x, 4x squared. These should always match. If they don't, either check your division or check your multiplication. And then 4x times negative 2 is negative 8x. And now remember, when we subtract, we're subtracting this whole thing, so you can write it like this. The way that I prefer to do this, if you remember when we were subtracting polynomials, we changed the signs. So I'm going to change this to a minus, this to a plus, because subtraction is adding the opposite. So now if we go straight down, these should always cancel. And then these, we have x, 1x plus 8x is 9x. Bring down the next term, just like usual, and repeat. So we're going to divide again. Divide the first term by the first term. So 9x divided by x. Those x's cancel, and we're left with 9. Positive, so we're going to put plus 9 up top. We're dealing with polynomials, so you're always going to have plus or minus in between those terms. And then we multiply. So we're going to go ahead and multiply just the 9 by x minus 2. So 9 times x is 9x. 9 times negative 2 is negative 18. I'm going to go ahead and just change both of the signs and subtract. And when we do that, these 9x's cancel, and these guys add up to 0. So since we have no other terms to bring down, this means our remainder is 0. And our answer here is what we ended up with up top. So our answer is 4x plus 9. All right, so the process seems really ugly at first. I know it's pretty confusing when you first see it. The more you do it, it's just kind of getting into the rhythm of things, divide, multiply, subtract, repeat, just that same thing over and over again. So let's go ahead and try another one. And this one has something special that we need to do with it first, and it's also written a little differently. It's written as x squared plus x cubed plus 4x minus 6 divided by x minus 1. So it's written with horizontal division. Same thing though, we're taking the one on the left, dividing it by this one on the right. And one thing that you can see in this polynomial here, it's not in kind of that standard form where we have it in descending order. And that's one thing that's really important, is it must be in descending order, both of the polynomials. So we're going to see that it has to be in descending order, and we also can't have any missing terms, which we will see in a couple of examples, but not quite yet. So for this one, what we want to do is rewrite it in descending order, and I'm going to go straight to our division sign. The x minus 1 is fine, that's in descending order. But this one, we have to start with x cubed, and then the x squared positive, so plus x squared, plus 4x, and then the minus 6. So we're going to rearrange it, make sure it's in descending order. And then we can divide. So we're going to take our first term divided by the first term, x cubed divided by x. You can think of this one, if you like, the quotient rule. 3 minus 1 gives you 2, so x squared. Put that up top. And then we multiply. So x squared times x is x cubed. X squared times negative 1 is negative 1x squared. And then we're going to subtract. I'll change both the signs. Just erase this stuff. There we go. Okay, so these guys cancel like they should. X squared, 1x squared plus 1x squared is 2x squared. Bring down the next term and repeat. First term divided by first term, 2x squared divided by x. Notice how we're always dividing by x. Whatever term is in the front on the outside is always what you'll divide by. So dividing here, we have a 2 and cancel an x, and we're left with an x. Positive, so plus 2x on top. And then we multiply. So 2x times x, 2x squared. 2x times negative 1, negative 2x. Change the signs and subtract. So minus, plus. And then let's go ahead and actually subtract. So these guys cancel. 4x plus 2x is 6x. And we have one last term to bring down. Make sure you bring down the sign that it has in front of it, so a minus 6. And repeat one last time. First term divided by first term, 6x divided by x. Those x's just cancel and we're left with 6. Positive, so plus 6. Then we multiply, so 6 times x is 6x. 6 times negative 1, negative 6. Change the signs and subtract. 6x's cancel out. Negative 6 plus 6 is 0. This is our remainder once again, so no remainder. So our final answer here is what we have on top, x squared plus 2x plus 6. All right, so let's go ahead and look at another example. Let's go ahead and do p cubed minus 2p squared plus 9 minus 5p all over p plus 2. So for this one, again, first thing we want to check is it in descending order? So the one on the bottom is good, constants last. The one on the top, we go p cubed, p squared, constant, and then p. So we need to switch these two terms around. So let's go ahead and set up our division. We're going to have p plus 2 on the outside. And then on the inside, we're going to have p cubed minus 2p squared minus 5p plus 9. There's our division setup. Now let's go ahead and start dividing. If you feel comfortable enough to start kind of going through and at least doing the first few steps without me, I would highly suggest pausing and doing that. It's really good to get independent practice, especially on these problems, because it's easier to follow along. I'm not going to say it's really easy to follow along because it's easy to get kind of lost in the work for these. But the more that you can do by yourself, the easier these are going to get. So let's go ahead and get started. So p cubed, first term divided by first term. So p cubed divided by p. Cancel out a p and we're left with p squared. So divide, multiply, subtract. So now we multiply. P squared times p is p cubed. P squared times 2 is 2p squared, so plus 2p squared. Careful with your signs. And now I'll change the sign, so it becomes a minus and a negative there. First terms cancel. Negative 2p squared, negative 2p squared. If we add those, we get negative 4p squared. Don't cancel them unless they're opposite signs. Bring down the next term and repeat. First term divided by first term, negative 4p squared divided by p. So we get negative 4p. Put that up top. Multiply. Negative 4p times p, negative 4p squared. Negative 4p times 2, negative 8p. Change the signs and subtract. First terms cancel. And then negative 5p plus 8p is 3p. Bring down our last term. And do this one last time. So first term divided by first term, 3p divided by p. P's cancel and we get 3, positive, so plus 3. And now if we go ahead and multiply, 3 times p is 3p. 3 times 2 is positive 6. Let's change the signs and subtract. First ones cancel. 9 minus 6 is 3. All right, so we don't have any other terms to bring down. So this one, we do actually have a remainder. So let's talk about how to write our remainders a little bit more. So we're still going to have this first part of our answer. We still have p squared minus 4p plus 3. And then with our remainders, you don't want to just kind of write it right next to the last term, because for these, this would mean multiplication. We don't want to multiply. What we're going to do is we're going to add it onto the end because we're adding on another term. And we're going to put our remainder, which is 3, over what we were dividing by, or the original denominator, p plus 2. So think of this kind of like taking an improper fraction and putting it into a proper fraction. You put it over the original denominator. And that's all we do with remainders. If it were a negative 3, just hypothetically, we could have put that negative on the top, or you could put minus 3 over p plus 2 instead of a plus. Either one of those would have worked. Neither one is correct or incorrect. I'll usually just put the negative up top just to kind of keep the formatting the same, just always have the plus sign, but either one is fine. Okay, let's go ahead and try another one, and this next one's a little weird. Yeah, let's go ahead and do this one. R squared minus 5 over R plus 4. So I'm gonna go ahead and start setting this one up, and then we're gonna change it a little bit, and you'll see why. So if I put the R plus 4 on the outside, R squared minus 5 on the inside, and you don't have to write down this part right now, because we're gonna be changing it. This is just to kind of show you why we have to do the next step. So let's go ahead and start dividing. R squared, first term divided by first term, gives us R. Then if we multiply, R times R is R squared. R times 4 is 4R. But if you notice, this minus 5 doesn't have an R. So these aren't like terms, we can't combine them. So what we have to do here is kind of fill in a missing, what we call a missing term. So let's go ahead, I'm gonna just erase this. We'll start over. What we're gonna do is we're gonna fill in missing terms. So we cannot be missing terms. And you might be wondering what missing terms are. You can kind of see what I was talking about in that example that we just started, because we couldn't line up that R because we were missing an R here. So you want all of the terms that come after your highest exponent. So if we look back at this one up here, we started with p cubed. That means we need a p squared, a p, and a constant. If we started with p to the 4th, let me make sure my pen's working. There we go. If we start with p to the 4th, we would need a p cubed, a p squared, a p, and a constant. So see how you have all of the ones that come after the highest exponent? That's what we're looking for. So in this one, since we have an R squared, we need an R, which we don't have, and a constant, which we do. On the bottom, we have an R to the 1st and then a constant, so that one's good. So what we're gonna do is I'm just gonna rewrite this as R squared plus, now I can't just add an R because that would change it. What we're gonna do so that we don't actually change this is add 0R. That means we're adding 0 to this, so it's not actually changing, but it is changing the look of it. So we're gonna have a place to line up the R terms when we go ahead and divide. So that's the big thing here, is making sure you rewrite your polynomials if you're missing a term. So let's go ahead and try dividing now. So we're gonna put R plus 4 on the outside. And then we have R squared plus 0R minus 5. And now let's divide. So we're gonna take our first term divided by the first term. R squared over R gives us R. Divide, multiply. So R times R is R squared. R times 4 is 4, so positive 4R. We now have something to line it up with, which is what we needed. Let's go ahead and subtract. So subtract, subtract. The first term should still cancel. And then we're going to have 0R minus 4R. 0 minus 4 is negative 4R. That 0 is just going to kind of keep this term the same because we're adding or subtracting 0. Bring down the minus 5 and repeat. First term divided by first term, negative 4R divided by R. Those cancel, we get negative 4. Multiply, negative 4 times R, negative 4R. Negative 4 times 4, negative 16. Subtract and change the sign, so change, change. First terms cancel. -5 plus 16 is 11. And there's no other terms to bring down, so that's our remainder. So let's go ahead and write our answer. We have r minus 4 plus our remainder, which is 11, over what we were dividing by, which was r plus 4. All right. Let's go ahead and try, let's do one last example, and this one kind of joins together everything we've been talking about. This is number 5. So this one's longer, and it's going to include some missing terms, some rearranging. Let's go ahead and take 2m to the 5th plus 6m cubed minus 3m squared plus m to the 4th minus 18 all over m squared plus 3. All right. Actually, let me go ahead and, sorry, I'm going to change this example. There's another one that's going to give you guys a better look at some things that could pop up in your homework and on the exam. So I want to do that one instead. That one was pretty nice that I wrote down. It didn't have a remainder. Let's go ahead and do this one instead. 2x to the 4th minus x squared plus 3x cubed plus 5 plus 6x over x squared minus 1. There we go. Okay. So first thing we want to do here is double check that everything is in descending order. And if we look at the top here, these are definitely not in descending order. We have x to the 4th followed by x squared. So first thing I'm going to do is rearrange those. We're going to have 2x to the 4th plus 3x cubed minus x squared plus 6x plus 5. And then on the bottom, this one's in descending order, but if you notice, we have an x squared, but we don't have an x. So I'm going to fill in that missing term. So the top was missing an x. This was not in descending order. So we're going to have an x squared plus 0x minus 1. On the outside, because this x squared minus 1 would go on the outside, it's not that big of a deal if you are missing a term, but you do have to be careful when you line things up, because there are going to be some things that don't line up as nicely. So I always like to fill it in. It kind of protects you from any mistakes you might make. And the top here isn't missing any terms. We have 4, 3, 2, 1 constant. Okay, now let's go ahead and divide. So I'm going to put this x squared plus 0x minus 1 on the outside, and then 2x to the 4th plus 3x cubed minus x squared plus 6x plus 5 on the inside. So this is a really good one to practice by yourself just to see if you have it down. The reason why I picked this one is because the remainder looks a little different than what we've seen. So don't be surprised if you get an answer at the end or a remainder at the end that looks a little different. We'll see that in a second though. Let's go ahead and start dividing. 2x to the 4th divided by x squared, first term divided by first term. Cancel out 2 x's, we're left with a 2x squared. And now let's multiply. And when we multiply, we need to multiply to every single term. The middle one's going to be kind of weird. So let's look at that one in a second. 2x squared times x squared, 2x to the fourth. Now, 2x squared times 0x, if you see how here in our next spot, we need an x cubed. So x squared times x is x cubed. But be careful with the numbers. 2 times 0 is 0. If we didn't have this missing term here, if we'd left this 0x off, we wouldn't have had an x cubed term, so you would have had to put your next term over here, but you still have to bring down this 3x cubed. So it can get a little funky, and it's kind of easy to forget that middle term there, so I like doing this just so you don't forget it. You can make it a plus or a minus, it's 0, it doesn't make a difference if you subtract or add 0. And our last term, 2x squared times -1, negative 2x squared. And now let's change all of the signs, so minus, minus, plus, and add straight down. First ones cancel. 3 minus 0 is still 3x cubed. See how it's really important that we had that term so we don't lose that 3x cubed. And then -1 plus 2 is a positive 1x squared. Bring down that plus 6x. Repeat again. So first term divided by first term, 3x cubed divided by x squared. Cancel 2 x's, we're left with 1. So 3x. Positive, so plus 3x. And then we multiply again. So I got 3x times x squared, 3x cubed. 3x times 0x, again, 3 times 0 is 0. X times x is x squared. And then 3 times -1, negative 3x. Change the signs and subtract, so minus, minus, plus. First terms cancel out. Again, for this one, you're adding and subtracting 0, so it shouldn't change it. We have 1x squared minus 0, still 1x squared. And then 6x plus 3x is positive 9x. Bring down the last term, so plus 5. And repeat one last time. X squared divided by x squared is, now make sure you actually divide this one. If you divide these, you get 1. So we actually need to put a plus 1 up there. One kind of common thing to do is cancel them out and put nothing. You have to put that 1. And now let's multiply. 1 times all of these. So 1 times x squared is x squared. 1 times 0x, 0x. All of these should stay the same. 1 times -1, -1. Change all of the signs, so minus, minus, plus. First terms cancel. 9x minus 0x is still 9x. 5 plus 1 is 6. Now, there are no other terms to bring down, so this is our remainder. It looks a little different because it has an x in it. That's perfectly fine. Remainders sometimes have x's, sometimes they're just constants. So now let's go ahead and write down our answer. We have this 2x squared plus 3x plus 1 plus our remainder, which is 9x plus 6, over what we were dividing by. Now I'm not going to put the one with the 0x. We're no longer dividing, so I don't need that. I'm just going to put x squared minus 1. And that is probably one of the hardest things that you will see in 95. It's not super common. It's not going to keep haunting you for the rest of the math classes that you take. But it is important. It will show up on the final exam and exam 3. So make sure you try it. Just make sure you know how to do it. And then in chapter 6, our final chapter, we're going to get into factoring, which is super important, and it is going to keep coming back for the rest of your math classes.